This is the prep packet video for Unit 4, Chapter 9.3. We're looking at objective number 6, in which we simplify more square root expressions containing variables. In this case, we're going to use some of the tools we've learned to break this up and simplify it. In this particular case, we have the square root of 8 times a to the 15 times b to the third. And what we're going to do with this is use our product rule and break it up into the square root of 8, the square root of a to the 15th, and the square root of b to the third. We can break up the first one into the square root of 4 times the square root of 2. 2 is prime, so it's done, but we'll take the square root of 4 and we'll end up with 2 root 2, and that's descending like that. For a to the 15th, we can take that into, remember 2 goes into 15 7 times, remainder 1. So we're done with that. And b, same thing, 2 goes into 3 1 time with 1 left over. Once you get to this, you can put them all back together. And remember, there's a certain order we like to do. We like to have whole numbers first and then what's inside the radical. So we'll have the 2 from here. Let me just do something really quick. I want to show you. We'll have the 2 from here, carries down to there. We have a to the 7th, and then we have the b. These are all the whole numbers that aren't outside the radical. What's left is the radicands, here, here, and here. And we're going to combine them all under one radical as the square root of 2 times a times b, which is how we end up with this part. So it's pretty simple if you just take it one step at a time. Let's take a look at these. So first of all, I'm going to combine these and see what happens. So remember, because of the product rule, I can combine these by multiplication. Okay, let's take a look at this. Now, what I would suggest for now, until you get a little better at it, is go ahead and just multiply those together. So you'll have 8 times 2 is 16, and b times b is b squared. You know that 16 is 4 squared, right? So if you take the square root of that, out's going to come 4b. Here we're going to use the quotient rule. Remember, we can do this. This is a completely legal move, right? And take care of your coefficients first. 2 goes into 18 9 times, and x goes into x to the 7th. If we come out here and think about this separately, you have, that's going to be x to the 7 minus 1 equals x to the 6th. So my next stop is to wonder, what's the square root of 9? Well, that's 3, so 3 can come out. And what's the square root of x to the 6th? Well, 2 goes into 6 3 times, so that's the square root of 9 times x to the 6th. This is getting a little more complicated, but again, if you take it slowly, it's not anything to worry about. Here, first I'm going to multiply my coefficients together, and I'll have all under the square root. 3 times 6 is 18. Then I'm going to match up the x's. There's an x to the 5th times x by itself would be x to the 6th. And then I'm going to look at my y's. Y times y to the 4th would be y to the 5th. And I'm looking for square roots. So 18 can break up into 9 times 2. So the square root of that would, in my newest version, will be 9 times 2, I should make that up there, times x to the 6th times y to the 5th. And I'm going to show you sort of how I do these. I don't really do a division problem over to the side. I think of it this way. The square root of 9 is 3, so that's done. The square root of 2 stays in there. 2 goes into 6 3 times, so that's x to the 3rd comes out, and I'm done with the x's. 2 goes into 5 2 times, and leaves behind 1. So what I have left, all of this is on the outside. 3x to the 3rd, y to the 2nd. On the inside is square root of 2 times the square root of y. One of the reasons I do it like this is A, it keeps track of what I've worked on already, and also it lets my brain say, oh, remember division problems? And it makes it a little easier to handle. Let's take a look at this one. Here I have 2k times the square root of 2k times the square root of 10k. I'm going to handle my coefficients first. So 2 times 10 is 20. And I'm going to do my variables next. And I just have one in each case, k and k. So k times k would be k squared. And again, I'm going to take this apart, and that's the same as 4 times 5. The square root of 4 is 2. That's done. That leaves behind the 5. The square root of k squared is just k, so that's done. And what I'll end up with 2k times the square root of 5. Here we're going to use the quotient rule again. Remember, I can write it this way just the same as I can the other way. And one of the reasons I've chosen to write it all under the radical is the fact that I can factor the coefficients and that I have the same variable, so I can do that too. So in the new version, 2 goes into 36 18 times. R to the 7th over R to the 3rd is R to the 4th. And again, I'm going to do this, and this is the same as 9 times 2. So the square root of 9 is 3. Cross that out. The square root of 2 stays in there. The square root of R to the 4th, well, 2 goes into 4 2 times, so it's R to the 2nd, and that takes care of that. So on the outside, I have 3R to the 2nd. On the inside, I have square root of 2. Now, this problem is one where some people get kind of confused, and they want to do a lot of work. But this is 5 squared times b squared, right? Well, that's just 5b, because that cancels it all out. If I told you this, you'd go, wait, why are you doing all that work? Because there's 5b right there. So that one is pretty easy, and you'll learn to recognize those pretty well. So go ahead and stop and copy, but before you do, I want to make sure that you go to do the U-Tries on page 542 and make sure you include the work with your prep packet. And that's it for Unit 9.3.